Hey everybody, welcome to week 9 of PS 398. Hard to believe, I know, but we are just pushing and getting toward the end. I hope you've been enjoying your problem sets, which I think have probably gotten a little bit more tangible. That map of France, that's very tangible, right? So up to this point, we've discussed either decision makers in complete isolation, rational choice theory or something like that, or we've discussed strategic interdependence of a simultaneous type. So up to this point, all of the moves that our players have played, be they countries or leaders or whatever, all of those moves have been simultaneous move. Now that simultaneity is not literal simultaneity, right? So if we're playing Prisoner's Dilemma, the two suspects, they're in separate cells. And that's what means that they can't see each other make a move. They don't get to see whether their opponent cooperated or defected. And that's what makes it quote-unquote simultaneous. Even if the exact clock time isn't the same, they make those moves at what can be viewed as if it's the same time. And that's been for everything. So even with Chicken, which is a model where time seems to be playing an important role, if we think about the cars driving towards one another, or if we think about the countries sort of continuing to push each other to the brink as they engage in their brinkmanship sort of thing, time seems to play a big role in that, but we still model it as if it's simultaneous because eventually there comes a moment, a lot of that time that's spent, we're just waiting. We're just waiting for the real action. This is just warm up. And then sort of the game gets real, right? And then something happens as if it's simultaneous. That final moment is as if it's simultaneous. So there's no time. You don't get to observe what anybody did before. And you don't get to condition what you're going to do on anything that happens after. Right? So it's all just, time plays no role up to this point, which is very strange because so many things that about international relations seem to rely on time. We observe and we react, right? It's not just be prepared for all contingencies and then whenever the simultaneous moment comes, whenever the cars are close to one another or whenever you're put into the separate cells or whatever, it's not like you suddenly then go, oh, now I'm going to think through all the contingencies. A lot of international relations is about seeing what other actors do and then reacting, right? And then we haven't talked about and then has not come up at all. Yeah? So the things that I see, the actions that I see happen before I make my decision. We haven't used the word before at all in this class. And when I'm making my decisions, I'm thinking ahead. I'm looking down the tree. I'm thinking what's going to happen if I go to the left, what will happen? If I go to the right, what will happen? And so I'm thinking ahead, but after, we haven't used that word either. So we haven't used before, we haven't used after, we haven't used react. We've been thinking about best response in sort of an abstract way where it's about thinking through all the contingencies, as opposed to thinking through what you will do, observing what happens, and then choosing what is best. So when we were thinking about best response correspondences, we said, well, suppose that your enemy was cooperating. What is best for you? And suppose they were defecting. But those are just hypotheticals. That's just a hypothetical. You're still just thinking through this in the abstract as a hypothetical. We want to move on to counterfactuals. We want to be able to say, okay, well, conditional on what happened, what will happen moving forward, and what would have happened in some alternate universe where another decision was made. Many of the key tools in strategic international relations rely on time. Two in particular come to mind. One is the issue of credible commitment. So if I make a promise to you today, whether it's a peace treaty or an alliance or a free trade agreement, if I make a promise to you, how do you know that I'm going to want to keep my promise tomorrow? Not today. It's easy to make promises today. Anybody can make a promise today, but how do you know that my promise is good tomorrow, which is when you're going to want it? Right? If I'm signing a mutual defense pact with you. We're two countries and we're signing a mutual defense pact. Presumably nobody is attacking us today. Otherwise we wouldn't be at some big gala. There's special pens. There's probably brie and pigs in a blanket. There's a big thing when we signed this. But then comes the day where we get attacked. And how do you know if I'm going to live up to that? Then, not today, then, in the future. You don't know. How do you know that my commitment is credible? How do you know that this is a big anarchy problem, right? So in domestic politics, if we sign a contract, we know that it will be maintained or or else we will have recourse. So if you don't live up to your end of a deal, then I can sue you. I can take you to Judge Judy, and we'll get this handled. There are legitimate institutions that reliably settle disputes and make sure that contracts are enforced. That's a today-tomorrow thing too, and the domestic institution of courts and litigation and so on, mediation, those are there to help us to have a better sense about time. But under international anarchy, credible commitment is a much bigger deal and a much harder problem, which means that the future is a much harder problem under anarchy than it is under institutions. The other big applications that you see in strategic international relations is learning or signaling. So if you don't know everything there is to know about me, you might observe my behavior. So you don't know how strong I am, for example. So you watch me fight. Today I fight. You learn how strong I am a little bit more. Tomorrow I fight. You learn how strong I am. Tomorrow, a little bit more. You keep learning. You keep getting a more and more precise sense about what I know. But you need time to do that. It needs to be a today. You get an observation. You update your views. Now it's tomorrow. You get more information. You update your views. We need to talk about time. How are we going to talk about international relations if we can't talk about credible commitment and we can't talk about learning and signaling and feigning and bluffing and all these things? If there is no time, none of these concepts have any bite. These concepts do not matter in simultaneous move games. So we're going to move on to the next big branch of applied game theory. Up until now, we've been living in one quadrant of what you can view as a 2x2 typology, where there are two variables in question. That's what a typology is. So on one, you can think, oh, is there complete information or is there incomplete information? Does everybody know everything about the game, or do some people know more about the game or other things about the game than others? Do I know things about my utility functions that you don't, and vice versa? Up until this point, we've only discussed models of complete information, and we will continue to do so for a few more weeks. The other dimension in question is whether the moves are simultaneous or sequential. And up until this point, we've only been talking about simultaneous move games. And so this top left quadrant of this typology, that's the land of vanilla Nash equilibrium when we're looking at simultaneous move games of complete information. So lectures 6, 7, and 8 have been entirely about simultaneous move games of complete information. Prisoner's Dilemma, Chicken, all the games we've discussed up to this point have been in this one quadrant. And now we're moving over to this quadrant. This quadrant is complete information and sequential moves. This is the world of extensive form games, and where we will eventually use the analysis tool of subgame perfect equilibrium, which is just a refinement of Nash equilibrium, as you'll learn over the next few weeks. Extensive form games explicitly incorporate the concept of time. Now, it's not clock time, it's not literal time, it's not like the people that are involved are going to be saying, oh, well, at 7:42 in the morning, I will play Acquiesce. It's not like that. It's a stylized version of time where some moves precede other moves. Some moves are observable before some decisions are made. And some are made after, so that we can look down the tree and think hard about what will happen in the different contingency time horizons. Extensive form games and subgame perfect equilibrium, these are very popular concepts. You may have seen these in some of your other classes, even without knowing it. These models are very common throughout political science and international relations and the social sciences more generally. Subgame perfection is one of those core tools that you'll see gone to again and again and again. One nice feature about extensive form games is they're going to give us tools to help us to better understand bargaining problems. Up until now, we've only thought about one way to turn a disagreement point into some Pareto frontier hugging distribution. We talked about Nash bargaining, but we haven't talked about the ways that states or other actors under anarchy make deals in bargaining problems. And I think you'll see today in the B block that there's a very nice way to think about bargaining procedures, bargaining protocols, in a way that explicitly incorporates time and also comports with our views about what bargaining looks like in a procedural sense. So this should be a very exciting lecture. My hope is just to introduce some of the fables. So a lot like the game, the strategic form games lecture, I hope that I can just introduce some fables to get your orientation set, just to get your appetite wet. Wetted, wet, wetted. What do we think? Wetted. I don't know the past participle of that verb, which doesn't put in any small minority. So my goal for today is just to show you some extensive form games and to tell you some of the fables that include time. So much like games lecture, I think that what the story is and how it ends are two very different things, and we'll talk about how to analyze these next week. It's very straightforward and intuitive. It will be one of the easiest things that I teach you. And so I think it's just going to be fun for us to talk through some of these canonical time-inclusive fables. I'll talk about 3 different classes of them. I'll try to point out different terminology along the way. You should just be able to sit back and listen to some of the stories, I hope. And we'll talk about how to get to the end of the story next time. So in the A block, I want to introduce the concept of an extensive form game by way of 2 examples. They're related. The idea here is I want to look at sort of opt-out games. There are 2 that come to mind. One is just a simple, straightforward model of deterrence. You know, one country is thinking about attacking another country. They have to look ahead and say, hey, what will happen if I attack my potential target? Then we'll extend the logic of deterrence games to talk about audience costs, which are a very influential idea in international relations. You'll see that the structure of the game doesn't have to be modified very much, but the substantive story does. We're going to talk about 2 very different stories that will look aesthetically very similar in terms of how they look on the screen, but with completely different narratives underneath. And those differences in the narrative highlight the fact that, the commitment that we're making is somewhat fluid. This is just a different way to think about time, but you can tell different kinds of stories. Time doesn't necessarily mean you have to only tell happy stories or you have to only tell sad stories. Time is just a feature that we have to include. There's lots of different things that it can do. In the B block, I want to move on to a slightly more advanced but not very much concept. I want to talk about what happens when the choice is a little bit more continuous, when the choice that one of the players makes is a little bit more complicated. And the standard way to introduce that is through the Ultimatum game. So I'd like to introduce the Ultimatum game, and maybe an extension or 2, just to get you thinking about bargaining processes as they play out over time. What does a bargaining protocol look like in a way that explicitly incorporates time? We're going to revisit that thought a few more times as the class continues, but this will be really this might be a big aha moment for you, because it's not just about the sale, right? So bargaining isn't just about the problem. The problem is the problem, but we have to select a procedure to try to analyze the problem from. And the Ultimatum game will be your first such procedure that's explicitly game theoretic. And then in the C block, I want to talk about an additional feature that gets included in extensive form games called information sets. Information sets help us to model the visibility of actions. They help us to better understand which previous actions are distinguishable from one another. And in order to introduce that concept, I'll show you a nice simple model of leaderly repression and the rule of law. So it promises to be a substantively interesting day, even though we're going to be talking quite a bit about sort of this workhorse set of tools, this set of extensive form games. I hope that by doing it by way of example so much, you'll get a sense about the underlying stories that we tell using these tools. The stories and the tools are beginning to come together a little bit more. And I hope that sharpening of the view is something that is helping your understanding. As we get further and further, not only do the topics get a little bit more tangible, but you're getting faster. You're getting more nimble. So I think you're ready, and you probably feel like you're ready. We agree on something. That's great. So I hope that this is a fun one for you. It should be a little bit of a breather, which is good. You've been working really hard. Let's get started. So I want to introduce the concept of an extensive form game by way of example. But before I do that, I just want to let you know what you can expect to see here in the next few minutes. So the key thing that I'll be showing you is decision trees. So this will be very visual. You'll be able to see processes in a stylized depiction. So the games that I'll be showing you today will have 3 main kinds of components. And then here in the A block, there'll actually only be 2. I'll wait for the C block to introduce the 3rd component. So in these introductory decision trees, like in the A block, you can expect to see some nodes, which are just dots, and some edges, which are just lines. This is what allows us to create a decision tree. These are the building blocks of decision trees for us, our nodes and edges. Let me start with nodes. In today's lecture, you'll see two different kinds of nodes in our game trees. The first are decision nodes. At a decision node, one of the players faces a decision, as you may have guessed from the name. So the idea here is that every decision node is controlled by one and only one player who has a set of actions that can take place at that node. And you'll see this by way of example here momentarily. I just kind of want to give you a chance to see the pictures, give you a little bit of a legend here to work with. So decision nodes are controlled by players. The other kind of nodes are terminal nodes. And terminal nodes represent the end of the interaction. So a terminal node is what happens after all the decisions in a given chain of decisions have been made. In particular, terminal nodes are what we will be assigning utility numbers. So we're no longer going to be thinking just about action profiles because there'll be too many different kinds of profiles to think about. Although on your problem set, you'll see that there's a deep, intimate relationship between standard decision profiles like we've studied and these decision histories or terminal nodes that we'll be studying moving forward. So we've got two kinds of nodes, decision nodes and terminal nodes. And in between nodes come edges. Edges are just lines that link two different nodes, be it two decision nodes, a decision node and a terminal node. And each edge, each line in our graph will represent a possible choice that could be made. Okay? So it could be left or right, it could be up or down, it could be fight or not fight. But every edge will be labeled with the name of a strategy. So nodes are players or endings, and edges are choices. Okay? And I'm describing this awfully right now. It'll all be easier when you see it. I just didn't want this to get too visual on you too fast. So I want to start with the simple, straightforward model of deterrence. Deterrence is an influential idea. Its influence ebbs and flows in international relations. It depends on how many recent crises there have been, I think. So the main idea of deterrence is that if I'm a country and you're a country, and I start some limited annoyance against you, I might challenge you, I might undermine your interests, I might start a small conflict, I might start a proxy war, I might go after an ally of yours, something challenging. I have to do so thinking about the shadow of the future. I have to think about what your reaction will be if I do that. If I don't do anything, then we live in a status quo world. We stay exactly where we are. But if I do something, then I introduce the possibility of you responding to my challenge. And the question is, does what I expect you to do in the future deter me from challenging you today? That time logic, what's the concept of deterrence if there isn't a future to think about? So the idea here is that we're going to draw this game tree and I'll model time going from left to right. Okay, so time will flow this way. And one move will occur at the beginning of time. We begin from the beginning of time somewhere, and the beginning of time is controlled by state 1. They have a decision node at the very beginning of time. They have the first move in this game. So player 1 is here, or somewhere here. I never aim well. And they have two choices. They can either do nothing, they can issue no challenge, in which case we end up at a status quo situation. There's a terminal node there labeled status quo. So if country 1 doesn't do anything, then we wind up at a terminal node called the status quo. However, if they issue a challenge to country 2, so we've got this little tree here is telling us they can go down and they can essentially accept the status quo, or they can go up. And if they go up, then country 2 will have an opportunity to react. Time is moving this way, remember. So now, if a challenge is made, we've got a decision node for country 2, and they have two choices. They can either not fight, or they can fight. If they don't fight, then we'll wind up at a terminal node called capitulation, let's say. They'll capitulate to the challenge. And if they fight, we end up at a terminal node called war. And that will exhaust it in terms of this introductory game tree. So we've got two decision nodes, one controlled by country 1 and one controlled by country 2. Each decision node has a binary choice, one for country 1 and one for country 2. And there are three terminal nodes. There's the status quo terminal node, which is what happens if country 1 doesn't issue any challenges. And there's one where there's a capitulation. That only happens if country 1 challenges and country 2 acquiesces or backs down or doesn't fight or whatever we're going to call it. And then finally, there's the war terminal node, which is what happens if country 1 challenges and country 2 fights. So what we need now is to fill in some utilities for these terminal nodes. So the utility function here is going to read in essentially a terminal node. For now, you can just imagine it as something that reads in terminal nodes and spits out happiness numbers. Okay? So I've got 3 terminal nodes. I need to assign utilities to those terminal nodes for each of our players. Both of our players. So let's say in this example of the model that both players receive 3 happiness points for the status quo. And I'll put country 1's number first and country 2's second. So we'll call that 3-3. So in mixed strategy Nash equilibrium, we think about maybe the scales matter a little bit. We're going right back to the world where the scales don't matter. So these numbers are just denote rankings. Now, if country 1 issues a challenge and country 2 backs down from the challenge, if they don't fight, and we end up at the capitulation node, then we'll say that country 1 gets 4 happiness points and country 2 gets 2 happiness points. Right? So there's like a little zero something that happens. Oh, I'll give you 1 widget of happiness. It comes out of my account and goes into your account. And we'll say that if the war happens, let's call that 1 for both parties. So in this instantiation of the model, war is really bad. War is bad. Oh, we needed a model to tell us that. So just look at this model. This is your first extensive form game. This is your first game tree. We have a root node, we have a decision node at the beginning of time, right? And then the decision is made. Country 1 can either not challenge, and then in which case time isn't very interesting. We just sort of go to the ending immediately. They can opt out of the interaction. They can say, you know what, I'm not interested in this interaction. Let's go to the status quo. I'm done with this. And otherwise, country 2 can either do the same. They can either say, you know what, I'm done with this too. I'll pay 1 happiness point to just be done with this. Thank you. I'll opt out by not fighting. Or we can wind up at war. So this, what is it? 1, 2, 3, 4. 4 lines, 2 decision nodes, 3 terminal nodes, and 6 numbers. That's not a whole lot of, there's not a whole lot of ink on the screen right now, right? But we've just told a very complete story. We've just told a complete story about how the decision to challenge depends on what you think will happen in the future. Country 1 is looking down the tree and saying, boy, that 1-1 looks real bad. I do not want the war outcome. But that capitulation looks pretty good. So my status quo is 3. In the future, if I make a challenge, maybe I'll get 4, maybe I'll get 1. There's some intrigue in that. There's a trade-off, right? Take the 3 now or make a risk in the future. Think about what might happen. Introduce the possibility of a great outcome and an awful outcome in the future. And what happens depends not just on your choice at that moment in time, but on somebody else's choice at the next moment in time. That's what's cool about this, right? Is your player 1, country 1 has a tough decision here. Player 2's decision is kind of trivial, right? Country 2 is just kind of reacting like a robot, but country 1 has a really tough substantive problem on their hands here. And just to repeat, the reason we call this a deterrence game is that the question is, how do expectations about what will happen in the future, does that deter, does that awful 1 payoff for the war outcome, does that deter country 1 from issuing a challenge? Right, so the idea here is that maybe country 2 is very strong. Maybe country 2 is very strong, and that is what stops. Maybe that makes country 1's payoff for war worse and worse and worse. The stronger country 2 is, the worse war is for country 1. And so you can imagine that 1 for country 1 just getting worse and worse and worse as country 2 gets stronger and stronger and stronger. And that we would think, be more and more likely to deter country 1 from issuing a challenge in the first place. Whether that's true or not, we'll have to see. That's next week. Stay tuned. But we don't know just yet. But that's the tension. You know, the interesting thing before we resolve the tension is to know what the tension is. That's the tension. The tension here is country 1 deterred by the awfulness of that war outcome? which they only get to know about in the future after country 2 has made a response decision. So that's pretty cool. That's a cool model just to begin with. That's really cool, if you ask me. You can really see the role of time here. You can really see the role of expectation. Country 1 has to make decisions in expectation. Country 2 has to make decisions in response. They are reacting. Right? So one interesting thing that emerges in models like these are like, does the first mover have an advantage over the second mover? Does the last mover have an advantage over the earlier movers? That's sort of the interesting things here are, do the procedural structures that we impose when we say who is the first mover, does that procedural structure confer advantages, disadvantages, neither, something else? It's interesting. So this is your first extensive form game, the Deterrence game. I want to show you what happens if we extend it a little bit and tell a slightly different story about the ending, okay? So let's get rid of it. We'll end our conversation about deterrence and move on to the interesting concept of audience costs and how they play out in international relations. Again, we'll learn more about the role of audience costs in determining outcomes once we talk about how to analyze models like this. But it's more important that you know what an audience cost is, where it emerges. When somebody says audience costs, what kind of picture do they have in their mind? Anybody that says audience costs has a picture in their mind, okay? And the picture looks like this. At the beginning of time, country 1. Actually, let's go this way. Let's go this way this time. So at the beginning of time, country 1 can either issue a challenge or not. If they don't issue a challenge, we wind up at a terminal node called the status quo. However, if they issue a challenge to country 2, then country 2 has a decision to make. Just like before, they can either fight or not fight. We'll call this acquiesce. They can acquiesce to the challenge and say, no, whatever you want, country 1, sorry. Thank you for issuing a challenge to us, and here's what you wanted, and let's be done. So that goes to a terminal node called capitulation. Or they can escalate. They can say, you know what? You want to issue a challenge to me? Why don't you just name a time and place, and we'll meet there and have a nice conversation about it, country 1. Why don't we have a nice chat outside? Now, the difference between this model and the last model is that now country 1 gets to make another decision. So now we don't go directly to war because the crisis got escalated by country 2. Now country 1 makes another decision. They can either back down, or they can fight and then we go to war. So now it's like a 2-step process to get to war. Or now it's a 3-step process to get to war, whereas before it was only 2. And either way, that's the end of time. So now we've got 4 terminal nodes. One is the status quo, which is what happens if country 1 just doesn't do anything to begin with. They can just opt out. They can say, you know what, I looked down the tree and I don't like it, I'll just take this little one. I don't want to be part of this tree. The second possibility is the one where country 1 challenges and country 2 acquiesces to the challenge. We'll call that capitulation. The third is the one where country 1 challenges, country 2 escalates, and country 1 backs down. And then the last one is the one where country 1 challenges, country 2 escalates, and country 1 says, okay, fine, let's fight. 4 outcomes. So let's normalize country 1's payoff at the status quo to 0. So let's just say they get 0 at the status quo, and we'll say that country 2 gets 1 happiness point there. So 0, 1 at the status quo. Let's say 1, 0 at capitulation. So let's just say that whatever country 2 had, they gave it to country 1. So they capitulate, and then we just flip the happiness numbers. But the intrigue in a model like this is down at the bottom node. So we'll say that if country 1 backs down after their challenge was escalated, let's say that country 2 gets 2 happiness points. The idea here being that now they've got some more reputation, they look really tough, maybe fewer people will issue challenges to them in the future. And this is where country 1 gets the audience cost. This is where the audience cost lives. So I'll call this minus A. Minus A is the audience cost paid by country 1 if they issue a challenge, it gets escalated, and then they back down. The idea here is that you look like an idiot. right? You issued a challenge. Somebody called your bluff, apparently. And then you were like, oh no, mea culpa, sorry, I didn't mean to start a potential war with you. I don't know what I was thinking about. I should have taken the status quo. So that minus A, that's a parameterization of how stupid you look to your audience, to the people that live in your country. So you look like an idiot. Your population is very angry with you. You might be in a lot of trouble right now. And we'll say that if war happens, we'll use the bargaining model of war payoffs. We'll say P minus C1 for country 1, where P is the probability that 1 beats 2 in a war, and 1 minus P minus C2 for country 2. So this minus A, this audience cost, the initial idea was that this would be higher for democracies, right? So there's a couple of influential papers. There's a paper by James Fearon in 1994, and there's a paper in a book by Ken Schultz in the late 90s, where the idea here being that democracies have different kinds of coercive diplomacy. Audience costs, you'll see in the next couple of weeks, that makes signals useful. That makes audience costs are going to make the fact that it's more challenging for country 1 to make a decision is actually something that might benefit them, because then they wouldn't show up for a fight unless they were ready for it. Maybe that goes the thinking. And so the idea was that democracies had higher audience costs maybe than autocracies, because we can vote out democratic leaders that issue challenges that then they back down from. So if we're angry as citizens in a democracy at our leader for issuing a challenge that then got accepted and then they back down and look like an idiot, we can vote them out of office, and that's minus A. But then it occurred to some people not too long after that there's nothing special about democracies in terms of being able to punish leaders. Now, in democracies, it's institutionalized. There's an election coming up, and we're thinking to ourselves, well, if we don't like the decisions that were made by our leader, we can vote them out of office. In an autocracy, that is impossible. You're not going to have, there might be an election, but we know that it would be something more of a sham election. However, a coup could be staged, a civil war could be started, there could be an assassination attempt, we might cut the heads off of the leader instead. So maybe the minus A is quite big for autocrats because they face less institutionalized and therefore more plausibly severe punishments. So there's a nice series of papers. That idea first got started by a well-known IR scholar named Jessica Weeks. So these autocratic audience costs have been something on IR's mind for 10 years now. So this is a very influential line of thinking. This model can be extended. Actually, the introductory models were a little bit more complicated than the later models. The first few models about audience costs were harder than this. But it's very easy to pin the logic down with a simple introductory level game like this. Now, what's interesting eventually is that I will know my audience cost maybe, and you won't. Right? So I know how angry my population gets at me if I issue challenges that then I back down from, and you don't know that maybe. Maybe you don't have the same pollsters that I have. And it turns out that private information on audience costs might be an interesting source of wrinkles in a model like this. It's not too hard to imagine different sorts of wrinkles emerging. This is a very nice way to get started thinking about the role of domestic politics in influencing international decisions. That audience cost thing is all about how the domestic factors influence what is best at the international level for country 1. All of that is in, again, a very simple, succinct, compact game tree that anybody can understand. Very nice, simple, straightforward model. Notice that in both models, there's this possibility for opt-out. You can always back out. You can always back out. It's not that interesting when there's only 2 decisions, but you can imagine a model that kept going where we back out. There's always a chance to opt out. We could be interacting for a very long time. We could be interacting for an indefinitely long period of time if we let ourselves. Maybe we have an infinite time horizon. But that infinite time horizon might be cut short because at any moment in time, one of us has the opportunity to opt out and end the interaction. We can take the status quo. We can acquiesce. We can back down. Or we can sort of seize what we thought that we were cooperating with. So on your problem set, you'll see an extensive form game called the Centipede game, where the opt-out is a lot less friendly than the one where you back out from a crisis. So you have that to look forward to. But I think that this is a nice, simple way to get started thinking about these models. It's not that hard to see them, and seeing them, it makes the story come to life a little bit, I think. But these are the bare bones of our time stories. So the next thing that I'd like to do with you is I want to show you what happens if this decision that gets made by one of the players is a little bit more complicated. So if they're not finger games anymore, we need to come up with an apparatus to allow us to make decisions in a more complicated choice set. So the ultimatum game will be how we get started with that, and we're going to talk about that in the B block. So we should go to the B block. So one tricky thing is that decisions aren't always so simple. It's not always a discrete choice. Back down, don't back down, fight, not fight, acquiesce, challenge. You know, these things that you could depict this way. Oftentimes, we're thinking about more nuanced concepts like how do we draw a border between two countries, or how do we set a tax rate? How do we set a tariff? Where if I'm choosing a tariff, I could set any number, right? I could choose a 0%, I could choose 1%, 2%, but I could also choose 0.5%, 0.25%, 1/8%, 7/8%. So what happens when we have to make these sort of choose a level decisions? Not this make a choice, but rather choose a level decisions. And how does time influence our decision about how to choose a level? How do we strategically set a slider thinking about the shadow of the future? And in order to tap into that sort of idea, we're going to introduce a simple bargaining model called the ultimatum game. The ultimatum game actually will look exactly like the deterrence game to you. It's the same idea. Two players, each gets to make one choice, and then there's the end of time. Right, that's all exactly as it was. But what's going to change is that player one, state one, is going to be making a decision where they're setting the level of something. And what they set the level of will influence the terms of the negotiated agreement. So in other words, first mover, the first player, player one, state one, will choose a level where that level sets the terms of a bargained outcome. And then basically, player two, the responder, country two, will either accept that deal as it sits, or they'll send us to the disagreement point. So if you view this as sort of a bargaining model seriously reduced, you might see some cool things. Otherwise, it's just a nice way to think about continuous action spaces. So the ultimatum game goes like this. At the beginning of time, country one makes a decision. They choose some x out of a continuum. They can choose any x between 0 and 1. And in order to depict that, I'm going to draw this with this little Assassin's Creed logo, this little hoodie logo. So they're choosing one x out of this whole range, okay? No, and I'll just say it can go from 0 to 1. Okay, so we go from 0 to 1, and we choose some x between 0 and 1. Look, I can choose anything. So here's 1/2. Here's x equals 1/4. Here's x equals 3/4. I can just choose. That's what I'm doing when I pluck this. When I choose this x, I'm choosing one x out of this continuum. Okay? So this is the main aesthetic tweak here, but it's deeply substantive. This is about setting a level. You're choosing some x out of a range of possible x's. You're not making a discrete choice anymore. For any x that you could choose, there's another possibility that's very close to it. So that's the first decision. It's an x is chosen. Regardless of what x is chosen, after that x is chosen, country 2 can make a choice. Country 2's decision is binary. They can either accept the deal, and in which case we end up at a terminal node called negotiated settlement at x, or they can reject the deal, in which case we wind up at a disagreement point. If they accept the deal, then we'll say that the country 1 gets to have x. They get x happiness points. And country 2 gets 1 minus x happiness points. So one thing that makes bargaining is the fact that there are opposed preferences over the outcomes. And notice here that country 1 wants x to be high and country 2 wants x to be low. Right? So there, it's zero sum. And in this case, it's constant sum, and they add to 1. So x and 1 minus x always add to 1. And because of that, we're in bargaining land, right? We have a zero-sum situation for these negotiated settlements. Notice, I just want to highlight the fact that the x and the 1 minus x are not exogenous. They are chosen inside the model. Country 1 chooses the x. They set the x. They determine the terms of the possible offer. They set the happiness point for the possible happy offer. Okay? So that x that's not a parameter. That's a choice. And for now, let's say that if player 2 rejects the offer, then let's call that 0-0 for now. Now notice that 0-0 is Pareto dominated by any x 1 minus x, so long as x is between 0 and 1. And country 2's decision here is their choice is whether at the disagreement point or whether we take the happy offer. So the intrigue here, the time intrigue here is country 1 has to make an offer that's acceptable. It's true, they have a lot of bargaining power here in a procedural sense. They're the ones that get to choose that x. They determine whether or not we're at an x that's really good for them. Maybe they set x really high. In which case, the possible outcome would be really good for them. If they chose x equals 1 and it got accepted, they would get a full happiness point. But they have to make an acceptable offer. They have to be careful. They have to be careful. And the reason that they have to be careful is that if they don't make an offer that's good enough from country 2's perspective, if they make the wrong offer to country 2, next thing you know, their offer gets rejected and we're at the disagreement point. So that's a lot of nuance. Now they have to be thinking about player 2's decision. What's player 2 going to do in response? Are they going to get angry? Are they going to say, you know what? This offer is no good. I'm going to reject this out of spite. They need to make an acceptable offer, but they want that x to be really high. So making acceptable offers is in tension with what's best for them. They need to strike the right Goldilocks balance between making an offer that's really good for them, but not so good for them that it's bad for country 2, and therefore it gets rejected. Let's put this in a bargaining space. So I'll just draw a bargaining problem here. And you'll notice that we've got the whole x 1 minus x, that just defines this little frontier is just a straight line, right? That's just x 1 minus x. It could go as high as 0, 1 or as far to the right as 1, 0, right? Any line in between. The disagreement point lives at 0, 0. That's at the origin. And you can imagine country 1's decision as an arrow that takes us from the disagreement point to any one of these potential. If they choose an x, that's setting a point on the frontier. Country 1 is determining which point on the frontier is the point in question, which is the point that then has to be compared by country 2 to the disagreement point. So this is a procedure. This is what helps us to think about how to move from the disagreement point, or the potentiality of the disagreement point. How do we go from there to some negotiated outcome? We're really starting to get this all together now. You can really start to see these things, but you're going to see that the procedure that we choose for how to get from the disagreement point to the frontier will determine where on the frontier we wind up, if at all. Notice that it's a very standard move to say, if an offer is rejected, for conflict scholars, if an offer is rejected, then a war is fought, in which case the disagreement point might be P minus C1 and 1 minus P minus C2. That's very standard. So this is the very first bargaining model of war equipped with a full-on procedure for you. So if you see it that way, then we'll move the disagreement point. Let's say the costs are low enough that it moves it away from the origin, but it's the same thing. We're still just trying to figure out how to draw a line. We're still just trying to figure out how to draw a line from that disagreement point up to the frontier. Now let's just think about some different kinds of procedures. So I'll wipe away that little whiteboard. There's no rule that says that negotiations only get to have one round. I'm not sure if you've noticed, but many negotiations that transpire in everyday politics, international or otherwise, those negotiations take place over time. Not just one decision is made and then you either take it or leave it. This is officially a take it or leave it offer. Country 1 makes a take it or leave it offer to Country 2. They either accept or reject, and either way we're at the end of time, which might be peaceful and endogenous. The happiness that we get from peace is endogenous to the choices. Or it might be warlike. But there's no rule that says we have to stop there, so let's just get rid of that. So now we'll still have Country 1 make an offer to Country 2. So Country 1 chooses some X between 0 and 1. And regardless, Country 2 can either accept that offer or reject it. If they accept the offer, then we wind up at the same x1 minus x that we were just discussing, where the terms of that deal are determined by player 1's, Country 1's choice. However, if Country 2 rejects the offer, then that doesn't take us straight to a terminal node. Instead, maybe that takes us to Country 2 can make an offer. They can counter offer. They can choose some y between 0 and 1. So if they choose a y between 0 and 1, then they're playing the ultimatum game against Country 1, so they make an offer, and then Country 1 can either accept or reject that offer. And we'll say that if Country 1 accepts the offer, then we wind up at y, 1 minus y, just as we would have before. So that's just, it's like x1 minus x, except Country 2 got to pick it. And then if Country 1 rejects the offer, then we'll call that when war happens. And that'll be P minus C1 or 1 minus P minus C2, or it could be 0, 0, or whatever the disagreement point in question is. So this is your first example of what you might call alternating offers bargaining. Right? Country 1 makes a proposal, which Country 2 can accept or reject. If they reject, then Country 2 can make a proposal, which Country 1 can either accept or reject. You can imagine iterating that. I offer, you offer, I offer, you offer. Think about haggling. If you buy something off of the internet or something, you're haggling with somebody that you're trying to buy some used thing off of, and you're like, oh, I'll give you $5 for that. And they'll be like, oh no, I need 20. So they rejected your 5. They reject your offer of 5. And they say they need 20. So they issue a Y. They counteroffer. Now you reject that. You say, oh no, I'll give you 7. And then they reject the 7. They say, I can't do 7, but I can do 16. This is all just reject, 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 and choose a new X, choose a new Y, choose a new X, choose a new Y. We're haggling. 5, 20, 7, 16. I'll give you 9. Oh, I can't take that. How about 13? How about 10? How about 12? How about 11? I'll take it. Alternating offers. We can allow that horizon to be infinite if we wanted to. We'll talk about that model toward the end of the class. But alternating offers, that's negotiations. Right? If we're trying to figure out where to draw a border, we're saying, okay, we'll draw it here. And then somebody says, no, we can't draw the border there. Let's try this other map. Oh, I can't take that. Let's try this other map. Let's try this border here. This alternating offers might go on forever. However, the player's impatience will be problematic, as we'll see later on in the class. So this is the ultimatum game, and its cousins, the alternating offers bargaining models. And you'll see, it's just a bargaining model equipped with a very particular protocol. And we could choose any protocol we want to. It could be 1 iteration, 2 iterations, 5 iterations, whatever it is, infinite horizon. No matter what, that is going to have ramifications for what the ultimate outcome will be. But this really demonstrates the importance of time in how to set a level of something. We're going to choose a price. We're going to choose a tax rate. We're going to choose a border position. We're setting something. We're setting a slider strategically. And we're doing that in anticipation of our fellow bargainers rejecting offers and either taking us straight to war or some other nasty disagreement, or making an offer of their own and potentially making a great offer for them that we have to accept. Maybe we don't want to give them that kind of power. Make the best deal that you can so that the next offerer can't beat you. Regardless, we're going to be at the ultimatum game very often. This is one of my very favorite fables. I think there's a lot of beautiful richness in this set a rate sort of thing. This Assassin's Creed hoodie logo, this is a really big deal in terms of, you'll see there's a lot of nuance with the decisions that get made in these ultimatum games. When we analyze this game, you're going to remember that, I suspect. Okay? So you have that to look forward to, which is something at least. I just hope you can. That's pretty cool, right? That's real. This is just cool. This is also cool. This time stuff, the intrigue of time in international relations is just so huge. Now, I want to talk about what happens when we can't quite observe everything all the way perfectly, and this is more technical than substantive, but I want to show you a cool model that uses it. So, we're going to talk about the rule of law in the next section. So, see you in the C block. So I want to show you one last model, which will introduce two wrinkles. One will be the information set wrinkle, which I'll discuss momentarily. But the second wrinkle is that there will be 3 players instead of just 2. So this is a straightforward model about the role of the state, which has been a recurring theme for us already. And it's interesting in the sense that it explicitly introduces the idea that if a sovereign ruler oversteps her bounds, then so long as the people can coordinate on doing so, so long as they can engage in collective action together, then they may be able to create a credible threat that stops that ruler from overstepping her bounds in the first place. However, the coordination decision is difficult because the citizens must simultaneously decide, essentially, whether or not to throw the transgressor out. But the overarching substantive punchline of a model like this is, or the question is, can coordination by the citizens form a credible threat that stops rulers from overstepping their bounds and taking too much from the citizens? So this is a well-known paper. This is Barry Weingast, 1995, I want to say. Good paper. This is a cool paper. So this game has 3 players, a sovereign, we'll call them S, and 2 citizens, call them A and B. You can think about A and B as 2 factions of society that if they were to work together, they could be strong enough to create a credible threat against the sovereign. So in the simplest version of the model, and we'll discuss this model from a few different angles, but in the simplest version of this model, the sovereign always moves first. So at the beginning of time, the sovereign makes a decision. They can either not transgress against the people. By transgressing, we mean seizing wealth or not paying back loans, not paying off bonds. It might be something like full-on repression. So transgressing here is something nasty done by the sovereign. So they can either choose to not do anything nasty, in which case we wind up at a status quo, or they can decide to transgress against the people. They can seize their wealth, they can suspend property rights, they can subdue political powers or other rights and privileges, they can repress, they can do something nasty. And the idea here is that if they do something nasty, then that gives these 2 factions of society, A and B, an opportunity to coordinate on attacking, on trying to throw the sovereign out. So what we'll do is, for now, I'll say if the sovereign transgresses, then the next move is made by the A faction, player A, and they can either acquiesce and say, okay, fine, we got repressed, or they can issue a challenge. They can challenge the sovereign for power, but that will be insufficient. So the idea here is that either faction isn't strong enough by themselves. So they need to coordinate. And then after, either way, country B makes a decision, or faction B makes a decision either way, they can either acquiesce or challenge. And again, that would be insufficient if you challenged by yourself. It would be very bad if you challenge and then your potential compatriot doesn't challenge too. So now we've got this sort of, there's a 2, and then there's a 2, and then there's 2 2s, right? So it gets a little bit more complicated as we keep going. But in reality, there's something pretty simple happening for A and B. It's going to look a little bit more complicated for a moment, and then you'll see that it's actually kind of simple. Now, it would be very easy for the citizens, for the A citizens, the A faction, if their decision was observed by the B faction, that would solve the coordination problem. So if if the A faction challenged and was seen challenging by the B faction, they look out into the streets and they see the members of the A faction fighting in the streets, singing in French. It's Les Mis, apparently. And then it would be very easy. Then they would know, and it would be easy to coordinate because they would see what their fellow compatriot did first, and then they would, maybe they would challenge too. But the idea here is that actually, despite its time-appearing character, the A faction and the B faction will be making what is essentially a simultaneous decision because the B faction cannot actually see what the A faction did first. To show that in the picture, I'm going to introduce a device called an information set. What the information set does, and I'll show this with this little oval, the information set says that the B faction doesn't know which of the two decision nodes that they control they're at. They don't know where they are in the game. They only know they're at one of these two nodes. By linking these two nodes together, I'm saying country B knows that they're somewhere in this information set, but they don't know where. They don't know where for sure. They don't know if they're in the world where the A faction challenged or the world where the A faction acquiesced. So when they make their own acquiesce challenge decision, then they do so not knowing for sure what happened. So it's essentially simultaneous move in terms of what A and B are doing, which I'll depict explicitly momentarily. So an information set is just a way to link two or more decision nodes made by the same player. So here I've got two decisions made by the B faction, and I've linked them together as a way of saying B doesn't know which of these decision nodes they're at. Now, all of the nodes within a given information set have to be the same player, otherwise, well, you would know where you were because you're the only you there. And it also must be true that the strategies available at every decision node within an information set have to be the same. Otherwise, so let's just say that if the A faction challenged, then B can acquiesce or challenge. But if the A faction acquiesced, then B can either hearts or spades, where those are not acquiesce and challenge. Well, then if you saw that your available options were acquiesce or challenge, then you would be able to infer which node you were at. And if you saw that your options were hearts and spades, you would be able to infer which node you were at. So you have to have the same, it has to be the same player everywhere in an information set, and they have to have the same options available there, otherwise they'd be able to figure out where they were. And when we analyze games of this type, we never tear information sets apart. Information sets have to be respected. Information sets require constant maintenance and respect. We never disrespect information sets. We never violate information sets. They always remain intact. And the idea is that whoever makes the decision from one information set, in this case faction B, makes one and only one decision because they don't know where they are. They either acquiesce or challenge on the understanding that they don't know which contingency they're facing. So that's just a way of getting a little bit of simultaneity back in the sequential process. Right, this decision, this is where all the nuance is. So the idea here is that if the sovereign challenges, they can try to take more off. If they successfully challenge, right? So if they successfully issue a repression, if they do a nasty thing, and then the two factions fail to coordinate on challenging. So they transgress and there's a failure to coordinate, then the sovereign gets to keep 8 happiness points. 8 happiness points for that. However, if the two factions manage to coordinate on challenging, then it's 0 happiness points for the ruler. And if the ruler doesn't transgress, let's just say that they get 2 happiness points. Let's call that terminal node for now. And in future versions of the model, we'll say what happens either way. So they get 2 happiness points for not transgressing. We'll say that if no transgression happens, we'll say that the two factions each get 8 happiness points, so they get the full 8. 8's sort of like the highest number you can get in this game, for reasons that'll be obvious in the coming weeks. So the idea here is that faction A gets 8 points for not being transgressed on, and faction B gets 8 points for not being transgressed on. However, if the transgression occurs, then the payoffs for Faction A and Faction B depend on whether or not they both fought back. So if they both fight back, if they both challenge, if they manage to both challenge, then both Faction A and Faction B get 7 happiness points. The idea here being that it was the 8 happiness points minus some cost of challenging, minus some cost of fighting back. So in other words, throughout, challenging costs 1 happiness point. We'll say that if you're transgressed upon and that you don't manage to successfully coordinate, then you either get 2 happiness points if you didn't challenge, and 1 happiness point if you challenged. It's sort of like a stag hunt at that point in time. So in other words, transgress, acquiesce, acquiesce goes 8-2-2. 8 full happiness points for the sovereign, and 2 for the newly repressed factions A and B who didn't fight back. If the sovereign transgresses, and faction A challenges, and faction B does not, then we go 8-1-2. 8 full happiness points for the sovereign, 1 because you got repressed and you tried to challenge, and 2 for faction B because they got repressed and they didn't try to challenge. They don't pay the challenging costs. Same thing in reverse for the situation where the sovereign transgressed, A didn't challenge, they acquiesced, and B challenged. Then that goes 8-2-1. 8 for the sovereign, 2 for faction A, and 1 for faction B. And then finally in the world where the sovereign transgresses, and then both manage the challenge, they successfully coordinate on challenging, we'll say 0-7-7. 0 for the sovereign, and then 7 for the non-repressed because they successfully fought back factions who still have to pay that 1 happiness point because they had to fight. So basically the sovereign can opt out and just enjoy the benefits of being in office and let live and let live for the factions who are very happy there. Or they can repress, they can transgress against the people. And if they do that, it depends on whether or not the factions are able to coordinate. And actually, because this information set has to be respected, it's actually easier for us to depict this as a matrix. So I'm going to convert this to essentially a coordination game matrix controlled by 2 and 3. Factions A and B. So I can... And you can confirm for yourself that this matrix has all of the information that we just discussed from the terminal nodes, but it more succinctly summarizes the fact that there's essentially a simultaneous move problem for the factions who don't get to observe one another when they coordinate. And so essentially, that means that the sovereign has a two-choice, they have a binary choice where they can either take a node for sure, or they can let the factions play a game. You can play, if I transgress, that essentially introduces a new coordination game for the two factions. That's pretty cool. So we'll talk about this game pretty often when we get into the nitty-gritty of sub-game perfection next week. I just wanted to introduce it to you now so that this information set thing doesn't throw you off too much. We'll practice that on the problem set as well. I just wanted you to get a sense about what that looks like, but this is also a really cool story, right? So rulers may be deterred from doing nasty things the same way that countries may be deterred from starting wars, depending on the credibility of the threat that will happen after. They have to look down the tree, they have to think ahead. They have to say, what does equilibrium play look like in the future? What will the future decisive decision makers do? So here we've said the sovereign gets to go first, but whether that's an advantage or a disadvantage has yet to be seen because we don't know whether or not it'll be reliable for the two factions to coordinate on throwing the bum out if they get transgressed upon. So this seizure of power, this threat of coup d'etat, that serves a similar role at the domestic level that the ability to start a war does at the international level. It's all about credible threats. It's all about whether or not you are deterred by a sufficiently nasty seeming contingency that occurs in the future after you've made your choices. Now, none of this is that profound, but it's a huge upgrade over what we've been doing. We haven't been able to talk about that very much. So I hope this gets you excited because whether it's super international, super domestic, super IPE, super conflict, super theoretical, super applied, it's all coming together. Time really unifies a lot of different things that might seem disparate. We're sort of weaving together this interesting part of the quilt. And it's all about time and credibility and looking ahead or thinking about what happened in the past. How does the past condition what is best for you now? How do expectations about what will happen in the future decide what you choose now? That's really important in terms of strategy. And I'm really looking forward to analyzing models like this with you next week, but I think it's just fun to look at the fables first. So what do we talk about today? Well, we officially took our book of fables and added a wrinkle in time. You already used that pun once and it works every time. Every time. Time is everywhere. You know, these lessons play out in important ways in international relations. Whether or not a threat is credible, or whether or not the promise of a future payoff is reliable, these are important things to think through at the international level. There will be important substantive lessons for you to learn about time and how it influences strategic actors at the international level. But you didn't need the games to understand how time influences strategy or what is best already. I'd like to think that you don't all steal things from mini-marts just because you're good and virtuous people. But even if you weren't a good and virtuous person, one reason to not steal from a mini-mart is that you might get caught and you might get punished. So even though you would like that whatchamacallit bar that you get at the mini-mart, or whatever it is that you like to get at the mini-mart, no matter what, you wouldn't steal it, no matter how unvirtuous you might be, if you had reasonable expectations that you would be caught and brought to justice. So in other words, the prospect of future punishments is something that influences what we think is a good decision in the present. So there are negative inducements that hopefully deter you from engaging in bad behavior. Now, for every stick, there's also a carrot. It might also be that we offer you some future reward for engaging in positive behavior. So, now let's say that you were thinking about starting to work out. You want to incentivize good decisions. You want to say, okay, I want to incentivize it to be something, I want to work out every day, and I want to incentivize something that helps to make sure that I do that. Well, maybe you'd ask a friend to keep a gift certificate, like an Amazon gift certificate from you. Right? So you'd give your friend the Amazon gift certificate, and you'd say, please keep this gift card, and once I have demonstrated to you that I've worked out 30 times, please give it to me. Okay? So you might be trying to give yourself a carrot. You might be trying to use a positive possibility to incentivize doing something that might be short-term costly. So you use the future to change the incentives of the past. Of course, you should worry about your friends taking it. You should worry about your friend just stealing the Amazon gift card, because in the future, whoever has the last move on that one probably is just going to take it. I've lost many gift cards and no pounds that way. So I think that the time introduces all sorts of interesting layers to the IR fable narratives that we've been discussing. But I think it also introduces some deeper concerns that might not be quite as obvious, and it's with those concerns in mind that I'd like to conclude with a provocative thought. In the standard accounts of causation, a cause must precede an effect. Okay? So right now you're going to college. Congratulations. And although you might be doing that for lots of reasons, one reason that many people go to college is that they would like to get a better, higher paying job when they graduate than they would have if they didn't. You could even draw a little tree of that. You can either go straight to the workforce and get some payoff, or you could go to college at some cost. Right? We'll actually be doing a model of this toward the end of the class. And if you go to college, then you can either get a really good job, or you can get maybe the same sort of job that you would have otherwise, and you have the same job and you paid some costs. So you're thinking, I would like to make a decision today that causes good things in the future. The decision to go to college then causes some wage differential moving forward. Does schooling cause higher wages? So you go to school and then we see the wage, right? So the causes precede the effects. This seems to play out in the physical universe. So If I cause my water bottle to come to my lips, it's because I made motions prior to that. So I'm making motions, I'm grabbing, friction is happening, I'm moving. I'm applying force in very subtle ways. Lots of subtle forces are keeping this exactly where it is, right? I bring it to my lips, I drink it. Everything that I do influences the next position, and thus this causal mechanism takes what was over there, over time is now over here, and next thing you know, I have caused the effect of a slaked thirst. Oh, I'm so slaked. My thirst is very slaked right now. So I just want to repeat. Causes precede. But in the models that we've written down, there is a beginning of time. Country 1 moved first at the beginning of time. The sovereign moved first at the beginning of time. That was the beginning of time. So what could have caused anything? There was nothing to precede. Nothing preceded those choices. Those, from a modeling standpoint, occurred at the Big Bang. Nothing preceded it. Nevertheless, we will see that relatively systematic predictions emerge in models like these. So what could cause that systematic response to the strategic problem if nothing preceded the decision? I just said that causes precede. If nothing precedes the decision, then what can cause a particular decision to be made? Expectations. Expectations of what? Expectations of what will happen in the future. But causes precede. So can an expectation be a cause? Is an expectation our little hologram, and it takes the future, which isn't allowed to cause things, and it brings the future to today. If I expect that the citizens will revolt against me, and I choose not to transgress, what caused me to not transgress was my expectation that they would throw me out of office. Nothing preceded. So it is my expectation of the future that causes my decisions today. So we're really on this very narrow razor's edge. It's hard to say what causes decisions, particularly when those decisions are made early in interactions. Because that beginning of time means that nothing can precede. Everything comes after. We need some mechanism of expectations to bring the future to today enough to allow us to make systematic choices. Maybe cause is the wrong word. Maybe nothing gets caused in the strategic world the same way that causes emerge in the physical world. Maybe what is a cause for atoms is not a cause for decision makers. There are a couple of possibilities then. One is, what's the appropriate word? If cause isn't the right word for what an expectation does to my choices today, what is the right verb? Or could it be that cause is the right verb, but it means two very different things? It has two very different definitions depending on whether we're talking about a physical universe or a strategic one. If you have a firm answer to that, you should ruminate further, because that is one of the hardest questions you'll ever be asked, I think. What is a cause in the context of time and strategy? If you knew the answer to that, first of all, you'd be a billionaire because you'd be the world's greatest stock market investor. Second, you might be president because you'd be able to offer a complete contingency plan about what your foreign policies will look like. If you knew what causation was as it applies to time and strategy, you would be the villain in a comic book movie. You would be that villain that feels like they're more enlightened than everybody else, and so they get to take whatever they want because they're the one enlightened one. You would have a lot of power because you would know how to use time and causation together in ways that none of us really do, because none of us really knows what expectations are and how they cause our decisions. That's pretty heavy. And the stakes are really high. What is a cause? What is an effect? What is it for a cause to cause an effect? These are the deepest questions in all of science. What is a cause? What counts as a cause? What does a potential candidate cause? Whether or not an expectation should count as one is a difficult question. I think this just goes to show, though, that as we get deeper and deeper and deeper into the theory of games, or any theory, it's tempting to think that as we get deeper and deeper and deeper, we will get closer and closer and closer to simple, tidy, understandable answers to these deep questions. On the contrary, the deeper we go, the harder these questions become, because the more deeply we understand them, and the more humiliated we become by their complexity. None of this is necessary for you to properly analyze a game of this form. None of it is necessary for you to be able to understand the stories that I've been telling. None of it is necessary for you to compute the equilibria once we get to that. Nor even to interpret those equilibria in a meaningful way. All of this is the meta. The things that are outside of our insides. The things that lie so deep and so foundational that it doesn't matter how deep into any given theory we go, because these problems are just at the core. I think it's pretty cool that the deeper we dig in any given sandbox, the more we realize that it's all sand. But that doesn't mean don't keep pushing. It just means things are going to get even more fascinating. So, I hope you enjoy your problem set. I hope you enjoyed these fables. And no matter what, thanks for watching.